Hello to you all. I have to say, I'm completely blown away. You have had us working night and day, trying to keep up with you. We are 434 students who applied, 300 and I think it's 40 something, 350 maybe, that have already made it now to the WhatsApp group, the main WhatsApp group. So we're going to talk about two WhatsApp groups, the main group and then the subgroups. And this is the biggest class that we've ever had. We stretch across 27 different countries. It's almost like a dream come true. You could almost call it a nightmare because it's giving us sleepless nights. How to manage such a large group of interesting people. You guys who are interested in soils. Um, did you ever ask yourself ever in your lives that whether you would actually become passionate about something as common and unknown and relatively unsexy as soils? I'm really hoping that by the end of this, you guys, your minds are going to be blown. You will have relearned a whole bunch of things, new things, unlearned some of the stuff we've known so far, and relearned new things. You're my kind of people. A little bit about myself. My name is Sue Kahumbu. I am a Kenyan. I'm half Kenyan, half British. I was brought up in Kenya. And I'm a mother of three wonderful children, two little girls and a boy. I live and work in Nairobi. I am or was an organic farmer for very many years. And I turned and transitioned into organic from a very short stint of conventional agricultural production when I inadvertently saw my mother get sprayed in a spraying program she and I were conducting with pesticides. She became extremely ill. And at that time, my children were very young. My mother was very sick. And I thought to myself, what are we doing? Why do we have to produce food with poisons? How can we do things differently? And I vowed then, that was an absolute transformational point for me. I vowed then to start looking into safe food production if I was going to continue with producing food. And when I started looking into organic, I found a couple of things. A, there was not a lot of information in country at the time in Kenya. And B, it was so interesting because it was rocket science. It was not just copy what somebody else is doing. You needed to really farm with your eyes wide open, looking at all of the different ecological aspects that come together to produce healthy plants, healthy pest-free plants, and understand that pests are insects. I always say insects that have a right to live too, just like you and me. And they find their niche where they find their food sources like we do. So I started delving into organic, and for many years, I was producing organic. I had customers who then came to me and said, will you sell organic, your produce to us? And in a very short period of time, I was running 8 organic stores. I was training farmers across the country on organic production and bringing their products to the market and making sure they got the right prices and looking at the price differential, not because it was harder to produce organic, but as a reward for these individuals for being stewards of the land and stewards of the ecological systems within which they engaged and produced safe food for consumers. But over time, I began to be a little bit disappointed because organic just wasn't cutting it enough for me. There was still a lot of use of pesticides. Although they were biopesticides, they still killed. There were still actions that disrupted agricultural or soils in particular. And I didn't really know what it was, but I just felt like, that there was this looming global voice that was asking, will organic actually feed the world? And although we ardent organic supporters were standing up saying, yes, 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 part of me was saying, but it's still quite difficult. There's something missing. And the missing part was soils. I started looking into soils after watching the Kiss the Ground movie, The Soil Story. And I thought, wow, that's interesting. And they had a short course online, which I took. And then later on, I joined the Dr. Elaine Ingham famous soil food web course and started now really looking into soils. I bought myself a microscope and I started learning how to look deeply into soils to see the living life that we were being told was there, but we could never see. We were telling farmers, don't worry, do this, your soils are alive. But when a farmer had a problem, what we ended up with was solution providers providing very quick actioning solutions like kill these pests with this toxin. And where we were talking about keep systems alive, but keeping systems alive still ended up creating issues that were not very advantageous to the farmer. So there was loss of yield, there was, pest invasions or whatever it might be. But after taking the soil food web course and looking at the microbes in the soil and learning about soils, I thought, if I knew this 20 years ago, I would have been teaching everything differently. And that was a beginning of saying, I need to be able to take what I've learned and teach beyond the people around me, try and get this information out as far and wide as I can. And that was the birth of this course, the Soil Advocacy course. And we started with a very small group. The history, you'll love this. The history of this was border riders. For those of you that are in Africa, you'll know that the border riders are the motorbike riders, the taxi riders. The first Soil Advocacy course was a group of 30 motorbike riders. And they joined and we took them through a course. The course was designed to use them as messengers and teachers within their families and within their communities. And it was during COVID time. So it was when there was not a lot of work, a lot of people were at home, a lot of systems were shut down. So the Border Soil Advocacy class started, and of those 30 individuals, we then started getting more and more people joining and growing. And to date, we have trained over 300-400 individuals. But this particular class is the biggest class yet. And as I said, reaches across the continent, which is just fantastic. Some of the successes that we're seeing across the continent are mind-blowing. An example of one of our past students, Ipra, who is in Burundi. There was a question in the chat about translating this course being in French. Ipra took the course in English. He's from Burundi. He then took all of the class material and he's translated it into Kirundi, and he is now teaching and has an entire soil advocacy program powered by himself and his advocates on the ground. He's got 50 soil advocates trained now. They've taught already 350 farmers, and he did that in 6 months. And that brings me to, what is soil advocacy? What's it all about? I would be wasting my time if I thought that by teaching you and reaching out to you, we were going to make change in this space. If this group of 300 takes 5 weeks to teach, and another group, another 5 weeks, we're a population on the African continent of now over, very close to, I think, close to over, even more now, 1 point something billion. And most of us are farmers. So the aim of this soil advocacy program is to teach you, to teach many. You are the whole advocacy. The word advocacy in here is so that you continue in your work, in your space, within your families, within your communities, in your institutions. You advocate for what you're going to learn. Encourage people to join the class, but also start your own programs and start teaching outwards. So that's just a little bit about this. I hope that by the end of this course, I will have inspired you to advocate for soil microbe rights. And after all, as long as your life matters, and it does, so do theirs. So without any further ado, I'm going to say, strap yourself in and let's get into the first module. Okay, so let's start with our planet, okay? The Earth is 4.5 billion years old. And the latest statistics on human population, 2023 was 7.88 billion. Today we are 8.025 billion humans inhabiting this planet. The first organisms on Earth are thought to have been single-celled prokaryote microorganisms such as bacteria and archaea. These organisms appeared on Earth around 3.5 billion years ago. Billions, okay, that's a long time ago. We can hardly think in more than a few decades, maybe a few hundred years. We're talking billions, so think all the way back then. This was soon after the formation of the planet. The earliest known fossils of these organisms are found in rocks that are around 3.5 billion years old, and they're thought to have been the dominant form of life on Earth for the first 2 billion years of its history, okay? So not a lot happened. It was just those guys, the prokaryotes, the archaea and the bacteria for 2 billion years. These early organisms were likely to have been anaerobic, meaning that they didn't require oxygen to survive. And they used simple inorganic compounds such as hydrogen and methane as sources of energy. Everything needs energy. And they also likely played a role in the formation of the Earth's early atmosphere through the release of gases like oxygen and methane. Eukaryotes, or eukaryotic organisms, appeared about 1.6 billion years ago. They were more complex than the prokaryote organisms that had preceded them. They have a more complex cell structure with a nucleus and other membrane-bound organelles. Fungi are eukaryotes, and they're believed to have evolved between 1 to 1.5 billion years ago. And prokaryotes and eukaryotes exist together today. We are considered eukaryotes. So we've come from 3.5 billion years ago to 500 million. It's still a lot. It's a long, long time ago. 500 million years ago, land masses were concentrated in the southern hemisphere and were part of a subcontinent called Gondwanaland. The northern hemisphere was mostly covered by a shallow sea. The climate was warmer, more humid than today, with little or no ice at the poles. The oceans, there were oceans, and they were teeming with life, including many different types of what we call trilobites and brachiopods and mollusks, as well as the first fish, which were jawless. All of those microorganisms that I have described, very small, little, few cellular organisms. On land, there were no plants or animals with backbones, and the only forms of life were simple, soft-bodied organisms such as algae and worms. The atmosphere of the Earth also had a different composition than today, with higher levels of carbon dioxide and methane, which kept the planet much warmer. Oxygen levels were much lower than today, and the planet's surface was dominated by volcanic activity and frequent meteor impacts. Some estimates are that the carbon dioxide levels were above 4,000 parts per million. Compare that with our 421 parts per million today. The mutualistic relationship between certain fungi and mosses and lichens, so these are the small, single, and some multicellular first. They're not plants and they're not animals. They bridge that gap in between. Is thought to have originated around the same time, around 400 to 500 million years ago. Land plants, mosses and lichens that were first colonizing the terrestrial environment were in need of efficient nutrient acquisition strategies, and they formed mutualistic relationships with fungi to access nutrients that were otherwise difficult to obtain. Okay, I've used the word plants, but a lot of those algae and organisms in there, they're still sitting in that place of plant, animal, plant, animal. The fungi involved are likely those we now refer to as arbuscular mycorrhizal fungi. And you're going to hear me speak about arbuscular mycorrhizal fungi a lot during this course. By the end of it, you're going to learn how absolutely critical they are for healthy crops, for healthy soils, for healthy us. So mycorrhizal fungi are known to form mutualistic relationships with a wide range of plant species, including thousands of those we grow for food today. Now, here we get a close-up on the expansion of a plant's root capacity with the inclusion of mycorrhizal fungi, which is said to increase the plant's reach by 40 times or more than if it was left to its own root system. Imagine that. That's kind of like mind-blowing. The plant's own root system will manage to access nutrients and water and do what it does in a certain space. But with the reach of the fungi, if you can look at that picture on the right there and imagine it in a 3D sort of image, the reach and the partnership and the reach through that partnership is quite astounding. Okay? Now, plants evolved to use stomata under their leaves to produce simple carbohydrates through the process that we know as photosynthesis. And here the story changes a little from what we learned. Okay? Plants or trees share 30, 40%, sometimes even more, of the carbohydrates that they metabolize through photosynthesis as simple sugars as root exudates in the rhizosphere or the root zone to feed the soil microorganisms, mainly the fungi and the bacteria, in exchange for water and other minerals that the microbes make available to them. So the picture that I showed you before, the mycorrhizal fungi around the plant roots, they're not there for fun. They don't just happen to come there because that's the way they evolved. They actually are drawn there by the plant because the plant, through photosynthesis, feeds them, okay? And the microbes in the ground do this through stripping nutrients from the parent rock, sand, or clay particles using their acids and their enzymes. And carbon, as you can see then, is pumped into the ground through photosynthesis, and it's kept there in the bodies and the substances formed by the microbes. And in the process, this is what builds soils. So this is what we call the liquid carbon pathway. And we'll be learning a lot more about that as well. The root exudates are managed by the plants and are used as a strategy to recruit and shape that rhizospheric bacterium, okay? They will modulate it based on their needs. If the plant is young, if the plant is fruiting, if the plant is seeding, if the plant is going through a winter where it's shedding its leaf, they will modulate the different chemical signaling through those exudates and in the process draw the nutrients that they need by attracting the right microbes around them. It's quite amazing, okay? Since the composition of root exudates depends on the developmental stage and the physiology of the plants, it's not surprising that changes in environmental conditions, such as those related to shifts in altitude, climate, or season, think climate change, also affect the rhizospheric microbial communities. Soils are alive. This is a picture that you're going to see often. It's a picture of the soil food web, and it shows the interdependencies of all of the different microbes that you're going to be learning about in this course, how they work together, how they prey on each other, how they influence what is available in the soil, how they influence your soil fertility. What parts of our actions destroy them, disrupt them, kill them? And what parts of our actions actually encourage them and help them to really increase that their actions and thus fertility in the soil? Anyway, we're going to go back to our timeline. So back to where we got here. So Over time, our planet developed a balanced climate, freshwater systems, fertile land with plants and animals in the oceans, on land and within the land, by creating the means and a place for the carbon dioxide that was in the atmosphere. Remember, it was 4,000 parts per million. The means and the place was it began to be absorbed in the soils, the biomass of plants, in the oceans. Almost everything on our planet is made of carbon, and that includes you and me. Carbon is not a bad thing. It's in fact incredibly necessary. It is the balance of carbon dioxide that we have as a problem. So anyway, 2.8 million years ago, that's when we came along. And that's when obviously the oxygen levels were good enough for us. Carbon, I think, is about 280 parts per million. And it didn't take us long for us to start getting engaged in agriculture. Well, actually, it did take us long, because it was, when we were here 2.8 billion years ago, we've only really been engaging in agriculture in the last 10 to 12,000 years. But a lot of that was really rudimentary agriculture, using rudimentary tools, slash and burn, oxen plows, etc. In the process of clearing and burning and ripping up the soil, we did cause a lot of mayhem to the soil microbiome, but we were not many, so we didn't create that much damage. However, as we grew in numbers, and seemingly wisdom too, we grew our capabilities of enhancing agriculture, and we've been altering and degrading the Earth's topsoil now for a few thousand of years. However, the rate of soil degradation has accelerated in the last 100 years with industrialization. It's estimated that around 33% of the world's topsoil has been degraded over the last 40 years. Many of us in this group have lived through this period. Many of us in this group were maybe just not born if you were quite young. But the reality is, we've talked about 3.5 billion years and how the planet came to the balances that suited our evolution, and we've destroyed it in the shortest time possible. 33 years, we've destroyed, 40 years, we've destroyed 33% of the world's topsoil. And it's estimated that if we continue at this rate, then by 2050, we would have destroyed about 90% of the world's topsoil. And that begs us to ask ourselves, what are we going to eat? How, in hell's name, are we going to produce food for our populations? And we can see from these pictures that what we have done has resulted in a lot of climate catastrophes now, and we can feel them now as we look around the world. Some of them are completely and utterly out of control. But I don't want you to feel hopeless. I want you to know that this course is designed to help you be useful in trying to fix some of these big problems. In 100 years, we've destroyed ecosystems that evolved over 500 million years. Our learnings in this course are going to be based on the teachings, experiments, and experience of many greats in the field of soil microbiomes and regenerating ecosystems, including Dr. Elaine Ingham of the Soil Food Web School, Dr. David Johnson, Dr. Christine Jones, Dr. James White, Nicole Masters, as well as some of our very own students who've taken this course and are now practicing new learnings. Quickly touching on David Johnson, he explored the differences between yields of crops grown in different mediums and different composts, and he was investigating the drivers of yield. What was it that was making plants actually grow? He found that levels of nitrogen, phosphorus, potassium, and organic matter didn't contribute logically to increase yields. And you can see that on the graphs here. It is what we're told. It is how conventional agriculture works today. NPK, DAP, all of the chemical fertilizer inputs that we put in the soil, we're adding in this chemistry with the hope that we're going to improve our yields. But here the data shows that that chemistry was not directly and logically linked to increased yields. So what was it? What he found correlated with those yields was the ratio between bacteria and fungi. This is microbes, not chemistry. It was microbes that were driving increased yields, not chemistry, okay? And this is where we have to unlearn what we've learned. Because what this tells us is that soil chemistry is not as important for plants as soil biology. Back to this again, soils are alive. Functional soils have a functional soil food web, and it is this web of microorganisms that affect the ability of a plant to fully express its genetic potential. The soil food web is made up of a series of trophic levels, the first being the photosynthesizers, plants, algae, mosses, lichens, followed by the second trophic level made up of decomposing mutualists, bacteria, fungi, and nematodes. Yes, nematodes are important. The third trophic level is made up of shredders, predators, and grazers, which include protozoa. Fungal and bacterial feeding nematodes, again, you're going to hear more about these good guys, and microarthropods. The fourth trophic level includes higher predators like arthropods and more nematodes like earthworms, etc. We'll be using this picture over and over again in the course, as mentioned. And with that, I'm going to end this little presentation. I hope that it's given you a taste of what's in store for you during this course. It's when I first looked under a microscope, and I will be taking you through looking under a microscope towards the last few sessions in this course, and you see that living life. It really is the turning point. I think it is the turning point for all of us to say, okay, we get it. Microbes matter. They really, really matter. They create the matter that we survive on. I want to spend a little bit of time learning about you, okay? I wanted to spend a little bit of time learning about why you're here. I've read in the applications that you put in some of the wonderful reasons for you being here, but I would like us to turn the microphone over to you all on the floor. As mentioned in our house rules, this is the way it works. You put your hand up, we choose you, we send you a ping to unmute yourself. You can then speak. We then ask you also to put your camera on so that you can come in here beside me and we can have a bit of a conversation. We have a little bit of a chat. So you can come in, tell us about yourselves, wherever you're from. Oh, great, I can see some hands have gone up, wonderful. And we will do this every class that we have. There will be time for students to chat. In your smaller groups, you can chat in there as well, chat to each other, introduce yourselves to each other. I saw some individuals in one of the group already doing that, wonderful. Get to know who you're in class with. We've made sure that those smaller groups include individuals from many different countries. So get to know each other. And on that note, I'm going to let James or Mike take over the opening of the mics and bringing you onto the floor. And let's go.
Great. Thank you so much, Sue, for that wonderful presentation there. And the first person to give us his reactions is Isaac. I'm going to give you a prompt there to unmute. Kindly unmute and start your video. Isaac? Great. Yes, you had unmuted and you muted again. I've given you the, okay, that's absurd. Okay, come on, Isaac, you're
Hi, Isaac.
Yeah, hi.
How are you?
I'm very much fine.
And where are you?
I'm from Kenya, Kajiado County.
Fantastic.
Yes, and I'm very happy to be here. I'm expectant of, actually, I'm here to learn about soil, to get more knowledge about soil.
That is great, Isaac. I hope that you can hear us. I can see that you have frozen.
So that is why I decided to join you. And up to now,
Okay, Isaac, your network is not very good. Do you want to just try again quickly? So this is one of the things that we will be dealing with, guys. We are dealing with network connectivity issues across the continent. So this won't be as smooth sailing as maybe if this course was being taken somewhere where we all had very stable internet. And we will try to, when you are speaking to us, go to the best place around you where you've got internet connectivity. I mean, there's always I call it a monkey in the mix, and I laugh about that today because we had Murphy doing everything. Half an hour before this class, my electricity went, and I thought, okay, here we go now. What do? We have no power. And then a tree fell down on my driveway because there was a strong wind. And when I went out to try and sort that out, a monkey came in the house and stole an egg off my table. And I'm just like, it is the way we roll. We roll with the drama and we get on with it. So thank you so much for being the first to brave the floor. And let's move on to the next speaker.
Yeah, and now the next speaker that I'm bringing on board is Ruth. I was seeing Ruth here. Please, Ruth, and unmute and put on your camera. Welcome.
Hello. Can you hear me?
Yes, very well.
All right. Thank you very much for having us for this class and this course. I'm a farmer. I am in Kenya. I would say I am a medium scale farmer. And I know that it's very, very important to go organic. But I have been having concerns about how to transition because of the obvious things that you mentioned, like yield, and cost, the cost it takes to farm versus the yield. If I just stop completely, for example, using fertilizer, and the fear of just making losses until I can make that transition where I make my soil healthy. So I think I'm very interested in terms of how to make that transition. I'm glad to hear you did it. I'm looking forward to hearing how you did it. Thank you very much. I look forward to interacting more.
Great, and thank you, Ruth, for that. It is a scary place to come from what we know, especially around the agriculture we know, with all of the costs, with all of the poisons, with all of the toxins, with all of the risks, to something that we don't know very much about. And that's why I say it's so important that we get to know about the motherboard. The motherboard of any instrument that you have is extremely important. The motherboard of your computer absolutely relies on it, and everything else sits on top. You can't fix what's on top if there's damage in the motherboard, and the soil is a motherboard of life. The soil microbiome is the motherboard of life. So through this course, you'll start thinking differently about the actions that you take. A transition from conventional agriculture to just stopping pesticides and stopping fertilizer and stopping whatever is probably not going to get you the results that you want, because just stopping means that you're stopping feeding any soil microbiome that is there. They need to be fed. If I gave you, if we take an analogy of 100 cows, and you now keep your cows in a zero grazed unit and you bring the food to them, and then we say, don't bring the food to them because they're not that healthy, let the cows out. The cows still need food. If we just let them out into a concrete pen, they're going to die. So that transition has got to start here. It has to start with us understanding at a cellular level in the soil what is going on. Because then every single action and reaction we will take will be based on what we've learned and what we're seeing. And it will give you the confidence to make the transition straight away. And I don't want to use the word organic as much as I want to use the word regenerative. I sometimes feel that organic switches out inputs, switches out synthetic pesticides with biopesticides, synthetic fertilizers with biofertilizers. And all of these still impact the soil microbiome and the biome on the plants and the biome on and within the seeds that you're going to learn about. When you start learning about microbiomes, these small little microscopic life that is the motherboard, and you start learning how to nurture those, that transition will be, as I've said, done with confidence and with success. So stay tuned, don't miss any of the classes. And I'd love to hear at the end of the class what you're thinking then and how you'll be changing some of your actions and activities based on what you learn.
Thank you so much, Sue, for that. And maybe somebody from outside Kenya now, if Katia Robinson.
Oh, and by the way, everybody on YouTube Live, I see you. We've got 33 students who are on YouTube Live. You can post any questions that you have into the chat there, and I will pick them up. I've got YouTube Live in front of me here. I can see the chat. I see you, Emmanuel, Godwin, Wilson, Remy, Vanessa, Valencia, Emmanuel, another Emmanuel, Rose, Esther, Godwin, and another Emmanuel, another Wilson. I see you.
Yeah, that was going to be my next comment, but you took it first. Fine. Now, Robinson, I'm going to, you're gone. Okay, you are there. Kindly unmute and turn on your video.
Oh yes, thank you so much. I hope you can hear me. My name is Robson Katia, and I come from Uganda, specifically in a city called Fort Portal Tourism City. And I am so privileged to be one of the students who are undertaking this course. And of course, one of the reasons why I chose to be part of this is that I'm a farmer, and I have tried out the organic farming, though like from Sue, what she said, it's really a bit disturbing because of looking at the price of the products out there from the conversion agriculture, but also from the organic products that we do produce. It's quite challenging breaking through. So that is one of the reasons why I'm interested in this course, and also getting to know exactly how did Sue really break even from the organic agriculture. But then also I so happen that I work with an organization that is basically spearheading or that is promoting agroecology to many farmers, to actually thousands of farmers. And so these are the reasons why specifically I made a decision to join this, so that I can get more knowledge, be able to teach and change lives of other farmers. Thank you.
Rabson, thank you for that. That's great. It sounds like you are an advocate who is ready to start action. Tell me about agroecology. So you said that the organization you're working with is promoting agroecology, and tell me the difference between agroecology, organic production, and conventional production.
Okay, thank you so much. I must say that there is a slim difference between agroecology and organic production. Though there is a big difference between conventional and the two. So with conventional, we're looking at production of of food using the synthetic pests. With conventional, you're allowed to use the pesticides, the herbicides, and the rest. However, with agroecology, we are looking at 10 principles or the elements where you're looking at diversity on the farm. You're looking at the resilience on the farm. You're looking at other principles that may come in. So with agroecology, we look at how do we maintain, or how do we make sure that we do not destroy nature, we preserve nature for the next generation to be able to also thrive in it.
Great. And thank you for that. You mentioned a couple of words that are really important. One I'm going to hammer on about throughout this course, but I'll pick it up here because you mentioned it. That is diversity. So when we look at agroecology, absolutely yes, we're talking about diversity, and we're not talking about diversity of any one thing. We're talking about diversity in general, biodiversity, to be more precise. We're talking about biodiversity in pollinators, biodiversity in crops, biodiversity in microbes below the ground. We're talking about systems that enhance that diversity. Now, if we look at conventional production systems where we look at monocropping, imagine 1 acre of only cabbages. Okay? Very little diversity, very little collaboration between organisms that would help to improve any of those systems, because we have stripped the system. We have created a very reductionist production system. Okay, there is a word you will keep hearing in the regenerative space that is slightly different than agroecology and slightly different than organic, and that is no-till or low-till and no-kill. So the aim is, when we ask a lot of people, or a lot of people say to me, how do I move from conventional to organic or agroecology? What are the pesticides that I can make? What are the inputs that I can make? But more importantly, what are the pesticides? And the reality is, if you have pests, you need to know why you have pests. This course will teach you why you have pests. Pests are messengers of something going wrong. So we must look at them, pests, as messengers. If they were, the fact that they are there, we need to be able to read them. We need to be able to say, okay, what kind of pest? What is that pest indicating? Is it a chewing pest? Does it have chewing mouth parts? Does it have sucking mouth parts? What is it telling us? It has come into our fields to eat. Pests that suck don't have to work very hard to get through the cell wall of a plant at all. They have very thin and very fragile sucking parts. So they have to go through very thin walls, cell walls. So if you see them, what they're telling you is your plants have very thin cell walls. And then you must address that. Why are the plants attracting these pests? And the stronger you make your plants, those insects that will feed on thin walls will go somewhere else, or they won't show up at all. So the idea is, again, reading that no-till, no-kill, but more understanding around that. So thank you very much for that. And I look forward to the next few weeks chatting with you and teaching you. I can see some questions on the YouTube live. I joined because I'm a farmer. I'm trying to, I joined because I'm a farmer. I can't read that whole message. Okay. A new farmer, starting with my 138 square meters of land and aspiring to go large scale and do advocacy to save our planet by encouraging other farmers to go organic. I hope that at the end of this, all of us are saying regenerative. There are a lot of words, but regenerative is regenerating and doing things a lot differently. They all amount to the same thing. We're all trying to do the right things, but I think the word regenerative agriculture really does encompass that regeneration starting from the soil up. In the chat here, I've got Abdel Musili, who says, I'm an agronomist, currently guiding farmers on hydroponic greenhouse farming in Macaroni County. I joined this program to learn how best to link regenerative agriculture with hydroponics, or even further, how to become the best soil resource health advocate by all possible means. Abed, I think that by the time you are finished this course, you will realize that hydroponics might not be the best way. Let's see how you feel at the end, okay? And then we've got Patrick Bahati, who says, I'm Patrick from Mooney University, a student in the agricultural field. I joined this course to get more insight about the soil ecosystem. Super Stanley, soil advocacy within the county of Siaya, is glad to be part of the team so that he can add more knowledge on maintaining soil health by accepting and adopting organic farming. I hope you're going to change the word to regenerative farming. Ruth said, I chose to join the course to help farmers improve yields in my region because the soils have lost fertility. And that is the biggest problem. And we are going to start off our sessions going forward on looking in depth at what losing soil fertility means and how do we know how fertile our own soils are? What simple tests can we do? And what does soil fertility, soil structure, and soil integrity have in common? And the common ground is the soil microbiome, okay? Let's see, we've still got some more hands up. And I do recognize we've got a very, very large group from Kenya, which is fantastic. I love that there are so many students. By far the largest group in this group are from Kenya. I love that we've got Somalia, Somaliland, Gambia, Niger, Nigeria, South Africa, you name it, Tanzania, Uganda, Burundi, Rwanda. It's really fabulous. And then a few places, other places, we've got a few people here from Hungary, and America and the UK and Israel and China even. So we all have soils. So yeah, let's see who's next. And Sierra Leone, Alex from Naivasha.
Demba, hi. Welcome, Demba. Unmute and turn on your video.
Greetings from the Gambia.
Yes. Hello, Pierre. How are you?
Yes, hi. I'm from the Gambia. I'm finally a student of the University of the Gambia, studying agriculture. A trained professional teacher, and I'm interested to learn about soil advocacy because I'm thinking of how to transition from conventional way of vegetable production, which is one of the requirements that students should have before completing their academic studies, that is their high school. So I would like to learn more about organic farming, which is more healthier, and I believe this course will help me achieve that. So as a teacher, it will help me to spread this new way of farming that students can embrace and also advocate it in their various communities. So that's one of the reasons why I registered this course.
That is absolutely fantastic. Teacher, a student, students, wonderful. And I'm seeing that there are so many individuals from universities here, which I just love, because I know that many of the universities don't, as of yet, actually have very in-depth courses on the soil microbiome. not only in Africa, but anywhere in the world. If we go back to 3 to 4 years ago, I think it was about 3 years ago, the EU actually started enacting policies and laws to protect soils. If we look at the SDGs, we have an SDG to protect things above the soil, to protect things in water, and to protect things on land. But there's not a lot of protection under the soil upon which we all depend. We now also have a call for, in the past, we have looked at ecology and given the names of flora and fauna, as in that encompasses plants and animals. And now there is a big call to include fungi, and that's the fungi. They were here first. They will be here last. They will be here forever. We all depend on them, but we've largely ignored them. So the new ecological descriptions are now looking at flora, fauna, and fungi, which is really, really cool. So yeah, lots to learn. And you know, if you're in positions to try to get soil microbial courses in your institutions, you know, that would be fantastic. I will be sharing with you a couple of speakers who are looking at intense genomic studies of the soil microbiome, and what they've learned and what you're going to learn through their learnings is mind-blowing. So looking again in the YouTube live chat, Grace Njiru from Kenya, Kirinyaga. I went over Kirinyaga the other day. It's beautiful and green. You look after those soils out there, Grace. Good to have you in the group. Michelle is a soil scientist. Yes, nice. I've joined this class so as to get better understanding of regenerative agriculture and composting, so as to teach farmers how to improve yields. I promise you this, you're going to learn how to make the best compost. Fantastic. Wairimu said, regenerative it is. I was exploring this recently. Glad to hear you're a student of Dr. Elaine. Talking about Dr. Elaine, let me tell you all something. Like us, Dr. Elaine Ingham offers scholarships as well. You can go to her, and we will share the links to the scholarships that she has. We'll share them in your smaller groups. Actually, in the big group, it doesn't matter. Let's call it the main group and the subgroups. In the main group, and apply for those scholarships. So far, since I've started teaching, 19 of my students, just like you, have been given scholarships by Dr. Elaine Ingham. And some of those students have gone on to now be given further scholarships to do the Soil Food Web consultancy course. And it's fantastic. So, you know, the world is your oyster. If you enjoy this stuff, if you're passionate about this, please do, when we share those links, get in there and follow them. Carmen, a founder of Urquanda Grow in South Africa. As a facilitator of change, I'm passionate about using community gardens and sustainably farming to connect people to the earth, improve food security, and foster growth. I believe soil is not just the foundation of our food systems, but a powerful agent for positive change in our communities. Excited to learn and share ideas on protecting and enriching soil for positive change. Thank you for that, Carmen. Ibrahim from Sierra Leone. He's here to learn about important information about soils. Fantastic. Now we're going to go back to the floor. James, over to you. Who's going to speak to us next?
We shall go in that order. You give each one 1 minute, 1 minute. We shall be through in 1, 2, 3, 4, 5, 6 minutes. And Joma, kindly unmute, and then you can contribute.
Hello, can you hear me?
Yes, we can hear you.
Yes. Start video, okay. Yeah, my name is Jama, and I'm a new farmer. Started farming in Somaliland 2 years ago. The first 6 months we have had success, good yield, good production, but then it all went south. We had a lot of pests, problems with pests, and the soil fertility didn't improve. We used a lot of pesticides. We used a lot of fertilizers. And then we had to move to another part of the farm, started again, and then tried to use goat dung, use organic matter. And then that had its own problems, because within 2 months, that whole hectare was taken over by Bermuda grass, which apparently the seeds were within the dung that we picked up. And we keep experimenting.
That's a great solution to planting Bermuda grass. Just get it into the goats, right?
Yes. So the problem is we are experimenting, and the two parts that we've struggled with is that the soil fertility, with or without fertilizers, and pests. And I've read a lot over this year, and apparently there's something you could do with the Brix index and the sugar contents of the plant to discourage pests, and the the plant structure to make the plant stronger and to discourage pests from attacking the plant. These are the kind of things that I'm trying to learn. Improvement of soil and improvement of plant, such that you can proceed and have something that is correct and repeatable. Because all what we are doing is we're experimenting, firefighting, having a problem, trying to fix it, moving on, and that doesn't generate revenue.
I like that, firefighting and experimenting. By the time you come to the end of this course, you will be thinking about the things you have said here today, and you'll realize that you're creating your own problems. Yeah. So the firefighting that you're doing gives you lots of knowledge. As I've said, if you want, we have an example in Kenya of a mining site at the coast called Hala Park, where there was mining for the cement industry. To regrow and replenish and rehabituate the entire old mine, they did exactly what you've spoken about. They used sheep and goats, they fed them acacia seed in their feed, and they let them out. And they went and planted them in their little round manure bombs. They planted trees, and those came up as a pioneer plants for the next plants that grew, etc., etc. And then they were taken down by the ladies and used for wood. So, what you've discovered could be a solution for something around the grass, if that's grass that you needed. But what you will learn is that, or the question you should be asking yourself is, how do I minimize the seed that will be distributed by my goats if I want to use goat manure as a source of nutrients for my plants? And it's possible. Compost it. Compost it using a thermophilic system, which you're going to learn in this course. Your compost will go up to between 60 and 70 degrees centigrade. It will nuke all the seed, but the nutrients are going to stay in the system through the actions of the microbes. And when you put that out on your land as a fertilizer, you will have not only a fertilizer, you will be inoculating the ground with the microbes that should be there, but you will not have your seeds coming through. So little things like that you learn will create big changes to the way you think and the way you progress. So good luck. And thanks for sharing.
I really look forward to it. Yeah, thank you.
Super. And next.
Nehemiah, please go next and unmute and turn on your video.
And whilst Nehemiah comes on, Wairimu, Remy, Baraka, and Grace, and Kimani, I'm Mama Africa. I've read your comments and thank you. I'm so glad that you're here with us. Nehemiah, over to you.
Hello, everyone. Can you hear me?
Yeah, we
Yes.
have a musician in the house. Woo,
Hello,
woo.
can you hear me?
Yeah. We hear you.
I think I'm struggling to hear you, so I don't know whether I can be in a position to confirm whether you can hear me clearly. But
I'm putting my thumbs up. I can hear you.
okay,
Yes.
thank you. So I can hear you clearly now. I'm Nehemiah from Kenya, working for National Potato Council. I think I've met Sue previously during a certain conference that was held by ALC at Karo Nal Ruakabete previously. So the reason why I joined this program, I'm actively involved in farmer training and demo trials. So I think this will capacity build me to be able to train my farmers, and I'm intending to join farming as a young professional, as a young farmer. So I think this will go a long way to help me to decide whether to go for organic farming. Thank you.
Okay. Nehemiah, how old are you?
Yes, I'm 26.
26. Great.
Yeah.
I'm glad that we've got young people in the group as well. I don't know what the average age of the class is. I should do a poll. But you are the future. You are the future of food security on our continent. So please be diligent, take notes, really learn. There is a space for you, whether it's in actual farming or training or teaching. There is a space for you. The knowledge that you're going to get from this course on soils, you'll be one of a minority that know about it in the country. So you'll become very, very valuable in this space. So, absorb everything you can, and good luck to you. Thank you for being here.
Thank you.
Thank you so much for that, Nehemiah.
Two, maybe.
Go ahead, Sue.
I was just saying we have time for another two.
Okay, I don't know who to choose. Number is growing, and I think Alex.
No, I think that we need to choose some women. I'm going to jump in here, and I want some women. Who have we got? Which women's hands are up?
Who is using Samsung? Either a woman, please put thumbs up. Okay, I don't know.
I'm going to just go with Rose, who is in the YouTube live feed. She said, I'm learning a lot of regenerative agriculture, having come from one of the driest parts of Makueni County in Kenya. I'm optimistic that these lessons will help us improve our soil and yields. And Rose, thank you for being with us. And they will. They definitely will. And there is a growing group, two of the first border soil advocates are leading a great movement in Makueni, and that is Sami and Husia. We may get them to come in and speak at some point about the advocacy work that they're doing on the ground in Makueni. So Makueni actually in Kenya is one of those that is leading. So yeah, keep up the hope, the optimism, and we can guarantee you that things will improve. Okay.
Oh yes, Nancy. I can see Nancy's hand is up for ladies, and then we go on unmute and turn on your video. Thank you, Nancy. Welcome on board. If you can hear us, please start speaking. Okay. Nancy, are you in a position to talk to us? Okay, she muted. Aha, okay. Pasa, maybe as we end that session, and so will guide us there. Pasa, please unmute, or Pesa.
Yes.
Go ahead. Welcome.
Name is Pesa Kusaga. I'm from Tanzania, and here it is night time. Don't worry. But the reason I joined this cause, actually, me and in my organizations and other like-minded organization, we are working directly to promote the farmer-managed seed systems, of which the local seeds are the major product in these farmer-managed seed systems. So we advocate for the government to recognize the local seeds and the farmer seeds in general. And one of the evidence we are using to convince the government, including the issue of climate resilience, but also the issue of nutritional value, which is available in these local seeds. The nutritional value, but also there is an issue of cultural value. But when you come to the specifically on the nutritional value, I know there is a relationship with the soil. Yes, so that's why I decided it's better for me to join this course to learn more and maybe share more experience from other countries to see the relations between the nutritional contents of the foods in relation to the nutritional content in the soil. Thank you so much.
Great, thank you for that, Pesa. So you're absolutely right. Agriculture is not just about growing things. Agriculture actually is about our health. And our health is dependent on the nutrients that we absorb. And the nutrients that we absorb are largely influenced by what we eat and what we can absorb. Our body, our capabilities of absorbing things, and then the nutrients that we consume. And the majority of those come largely from plants or from animals that have consumed plants. So it's absolutely critical. And there is a massive link between nutrients and different plants and different seeds and different production systems. You'll be happy to know that the last speaker, I bring in a guest speaker towards the end of the course. He is one of the leaders in nutrition in the world. And he's going to come in and he's going to talk to us about nutrient density and plants. We also will have one speaker that will come through with a video recording who will talk to us about seeds and our dependency on seeds that are produced, but that actually produce nutrient deficient plants, and how we need to get back to our own seeds and to grow seeds that can communicate. Remember that picture that I showed you of the plant and the mycorrhizal fungi and the big root network that there is? That's because that plant is communicating with the soil biome. Now, if that seed of that plant had been manipulated and grown in an environment that was sterile, that it would not succeed in that ground. It would be dependent on something else. And that's what most of our seeds are. They've been grown in and by means that are very heavily subsidized by synthetic fertilizers and pesticides, and they cannot grow properly. They're like injured seed. The same way if we were injured humans, we could not function properly. So we need to get back the power of our seeds and our indigenous seeds and for cultural as well as nutritional reasons, absolutely, like you're saying. Everyone, I'm going to have to cut us off now because we do try to stick to timing. It's now 8:30 Kenyan time. Whatever that is, in whatever part of the world that you're in, I thank you for joining us. Pesa in Tanzania, I could see that you were already ready to go to bed. Thank you for joining us, and I hope that you dream about soils and about tomorrow's class, where we're going to be going a step further and a step deeper into our journey in this conversation around soil. So on that note, and the way that we end our classes is very special. I am taken, the spotlight is taken off me, and we are all given open microphones and cameras so that we can all say goodbye to each other. We're going to go to that now. We're going to go to end of class ritual, which is everybody put your cameras on, everyone put your microphones on. We can spotlight. No spotlight has gone. Thank you. And we can all say good night to each other.
Night.
Thank you so much. Good night.
Bye.
Thank you.
Good night.
Tomorrow.
Night.
Night.
Thank you.
Night.
Bye and good night.